Hello. Today we will be optimizing the container of the best drink to consume in the morning. And that is orange juice.
Grab some sharp objects, brooms, and foreign tools. This is for every time you took my orange juice.
So to begin, we're going to take the measurements of the height, and then since it's a square base, we're just going to take the sides, and then it'll be equal to both edges. So if we start with the side in the metric system, because obviously it is superior, it is, let's see, about 9.7 centimeters. So we'll go ahead and write that in. And then if we take the height, we're not going to worry about this part. We're just going to imagine it's like this. That'll make it much more simpler. Plus, that's really what matters, right? Because there's no juice up top. And it's about 19.3, we'll say. And step 1 completed. So we're going to optimize the volume of this good old carton. So to do that, we're going to make our primary equation, volume equals, and for this, it's going to be s squared times h, because basically it's like width times length times height, but width and length are equal, so we can make it s squared. Then for our secondary equation, we'll make that surface area, and then the surface area of this, we'll say it's 2 of the top and bottom, so that's side squared times 2. We can put that in. And then that's going to be added with the side times the height times 1, 2, 3, and 4. And we can go ahead and add that to our surface area equation. And then since surface area is going to be our secondary equation, we'll have to figure out what surface area is of the carton, and we'll do that really quick. And that is our value, so we can go ahead and put that in. Boom. Let's go back and add labels. So now that we have our secondary equation, we can go ahead and solve for one of the variables. In this case, we'll do h. So we'll do 937.02 minus 2s squared, and then that will equal h, and this will be all over 4s. We can make these numbers smaller by taking everything divided by 2. So if we take that 937 divided by 2, we get 468.51, and then this will cancel, so we'll have s squared, and then we'll just have that over 2s. Same thing. Then we can go ahead and plug it into our second equation, and we'll do that right now. So when we plug this into our primary equation, we'll have volume equals s squared times all this. So we'll put 468.51 minus s squared all over 2s. And then if we want to solve this, we can cancel that s out, and then we'll have volume equals 468.51 s, because that will distribute, minus s cubed all over 2. Then we can go ahead and take the derivative. So the derivative of the volume would be 468.51. This s doesn't come with it, and the 3s squared, and then this 2, it's
coefficient,
but it would cancel, so then we wouldn't have to worry about in this, and then we can set this equal to 0. We can move that 3s squared to the other side. Divide that number by, oh, my calculator shut off. Divide that number by 3. Get 156.17 equals s squared. And then if we take the square root of that number, we get 12.5. So our optimized side would be, oops, 12.5 centimeters, that is. Now, we just got to find our height. So now that we know what S equals, we can take that and put it back into our secondary equation. So we'll have 468.51 minus 12.5 squared all over 2 times 12.5. And that is going to equal our H value. So we can calculate that on our calculator real quick. And we get, what do you know, 12.5. So our optimized shape slash measurements, whatever you want to call them, for this orange juice thing would be a cube. But it's not. Minute Maid, what are you doing? I guess we'll talk about that next. And if you wanted to figure out what your new optimized volume would be for your cubic orange juice, all you would have to do is put your measurements back into this, and well, if you take that and put it in there, well, it's really just going to end up volume equals S cubed, because, well, it's a cube. And when you do that with 12.5, well, you get that. So, 1,950.12 cubic centimeters would be your optimized volume for its surface area. The more you know. Well, let's just see how much volume that Minute Maid is missing out on. So if we take our original measurement and we put it into there, we would get volume equals 9.7 squared times 19.3. And if we do that, let's see what we get. We get 1,815.94. Oops. There you have it. So if we wanted to figure out what percentage of additional volume we would be adding if we use the optimized dimensions, then all we would have to do is take the optimized volume minus the actual volume and take that divided by the actual volume. So we'll go ahead and do that right now. And we would get 6.95% more volume if this thing looked like a cube. Now the real question is, why doesn't Minute Maid make their cartons in the shape of cubes? They could just save so much money, right? Well, I mean, when you pour this thing, perfect size for your hand, and then just look how smooth this thing comes out. This is not coming out this smooth if it looks like a cube. And you can just do it with one hand. It's so easy, right? So, in reality, they probably shouldn't change because it's super easy to pour, and then fridges aren't shaped like cubes, so when you put this in the top shelf, you know, it has to have some height. If it's too wide, then you're just going to waste out on so much space. So maybe the real thing is, we got to optimize a refrigerator. Anyway, thank you for watching this video. I hope you have a great day, and remember, orange juice is the best drink to drink in the morning. Goodbye.
You could say, like, I put my orange 4-inch door hinge in storage and ate porridge with George. You just have to figure out the science to breaking down words.